So, dear students, we will discuss what is linear transformation, what is identity transformation, what is zero transformation, or what is linear operators. So, we will try to discuss all this with some examples here. Okay, so a function t from a vector space Vf to another vector space Wf is said to be a linear transformation if and only if for all x, y belongs to V, we have this identity and this identity. So transformation of x plus y equals to tx plus ty. Another identity is transformation of alpha x equals to alpha of tx for all alpha belongs to f and xy belongs to v. That means a function t from a vector space B to another vector space W will be called linear transformation if for any two vectors x and y from vector V, this vector, we have these two identity, and these two identity can be put together in a single compact form as this identity. So from now onwards, a T will be called a linear transformation if it satisfies this identity. So this identity, that means from now onwards, given a function T, if we have to check whether T is a linear transformation or not, we have to verify this identity. Okay, so now what is linear operator? What is linear operator? Linear operator. So linear operator is a kind of linear transformation from vector space V to V itself. Okay, so linear transformation जो है, सॉरी linear operator जो है linear transformation का ही particular case है. उसमें t जो है, t goes from B to B itself. B से B में वापस आ रहा है. सो यहाँ ये वेक्टर और ये वेक्टर स्पेस दोनों वेक्टर स्पेस सेम है, सेम वेक्टर स्पेस में ट्रांसफॉर्मेशन हो रहा है. Then we say that this transformation is called linear operator. Okay, and what is zero transformation? What is zero transformation? Zero transformation. So zero transformation is also a kind of a linear transformation from vector space V to another vector space W such that tx equal to 0. So it means, so whatever the inputs you give to t, it will give you 0, tx1, tx2. So whatever inputs you give to t, it will give you 0 vector. Then we say that t is a zero transformation. So x1, x2, dot 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 xn, these are all vectors you take from these are all vectors from V, not from W. Okay, so whatever the inputs you give to T, it will give you 0. This type of transformation is called zero transformation. Then what is identity transformation? What is identity transformation? So identity transformation is also a particular case of linear transformation from vector space V to V. It is a particular case of linear operator. Whatever the input you give to vector, whatever the input you give to the function t, it will return the same vector. It will return the same vector. So t x equal to x for all x belongs to v. ठीक है, तो x का जितना भी एलिमेंट्स अब t को देगा तो वही सेम एलिमेंट सेम वेक्टर आपको मिलेगा वापस. Then this kind of transformation is called identity transformation. Then what is negative transformation? So negative transformation is also a kind of linear transformation from t from vector space V to W such that it is defined in this way. So if you give a negative quantity to t, you will give a negative vector. So negative quantity or negative vector. So this type of vector, this type of transformation is called negative transformation. Okay, now so before going to the properties, we should see some examples. Of course, you will see the example of linear transformation in the following pages. Like this is also an example of a this is an so this is an example of a linear transformation. So here actually linear transformation function is from v3f. v3f means you can write in this way also, r3 to v2f. v2f means actually r2 na? So here the vector space, this is b and this is w. Okay, so the first vector space is r3 and second vector space is r2. You can see you take an input x, y, z. So x, y, z, this obviously belongs to r3 na? So you are taking the vector from r3, so it is 3 tuple, means from r3, and it gives you 2 tuple vector. 2 tuple vector means this is first element and this is second element. It is separated by comma ना. So अब 3 टपल वाला एलिमेंट्स आपने लिया है x, y, z. आपको क्या मिल रहा है? 2 टपल्स वाला मिल रहा है. दैट मीन्स ये r3 का वेक्टर है, ये r2 का वेक्टर है. So this is an example. This is an example of a linear transformation. And how it is a linear transformation? So we have a proof. We can prove this, but in this video I will not prove. Maybe we can discuss in the next video how this is proved. So this proof is simple. You can even try yourself, or I will try to discuss in the next video. So another example of a linear transformation you can see here is this. So this is also an example of a linear transformation from vector space r2, from r2 to r2. So it is, in fact, it is an example of a linear linear operator, actually linear operator, because the space is same, no? So this is the case of transformation from b to b. So here b is r2, so it is r2. So this is an example of a linear operator. So this is an example of, this question is an example of linear operator. And again, how it is a linear operator, it is proved here. It is proved here. So you can try to see, or I will discuss it later. So these are some example of a linear transformation, linear operator. And you should also know what is zero transformation example. So zero transformation, okay, zero transformation, where is zero transformation? So you can see here zero transformation, here it is, and I'll define like this, but you can specifically define transformation from vector space b to you can define it this way: transformation from, suppose, r2 to r2, such that txy equals to 0, 0 for all xy vector belongs to r2 and element x and y belongs to r. So this is an example of zero transformation. So whatever the vector you take from r2, you get a zero vector, na? So you take any vector xy from r2, you get a zero vector, 0, 0, na? So this is an example of the zero transformation. Now example of identity transformation. So here also example we can simply write this one. So define a transformation from suppose R2 to R2 such that t is defined by suppose xy. It gives suppose xy itself for all for any vector xy belongs to R square, where x and y are some real number. X, y are from the field of real numbers. So that way you can give this kind of examples along with the definition. Okay, so we'll stop here.